On page 28, we are learning about function notation. Anytime someone is teaching you something about notation in the math world, it's usually referring to a way of writing or expressing things. How about that? Function notation expresses a function where you can input a value and there'll be a unique output dependent on what its definition is. For instance, here we have what we call f of x equals negative 3x plus 5. We pronounce the beginning of this the f of x. And f is usually like the universal one that they use, but you can use g of x or h of x. You can use different letters to show the difference between a couple different functions. Anytime I've ever learned this from a teacher, they've always expressed this as there's a machine here, and the machine has it's a function machine, and inside that goes a input, and then out of it comes an output, and that output is called the f of x. And so before we would say if you input x, out comes some certain y. Now we're going to say you input x and out comes some kind of variation of x based on what the function does to it. So the way that they use this is they will ask you to plug some number in for x. And this is telling me what function to use and what number to plug in for x. So I'm going to use the function up above that has the f. But if I'm doing f of 7, I'm actually going to go ahead and replace x with 7 and evaluate this and simplify it. So negative 3 times 7 is negative 21, and negative 21 plus 5 is negative 16. If I input 7, my output is negative 16. If I express that as an ordered pair, it looks like this. This one here asks us to input 3 into h and tell us what the output is. So here is h. Notice I just left a set of parentheses there because in the parentheses I'm going to be plugging in 3. 3 squared is 9. 4 times 9 is 36. And 36 minus 19 is 17. So my input was 3 and my output was 17. These ones are a little bit different because they're telling us what the output is, and then they're asking us for the input. So the g of x, that's right here. I'm going to put that here, 2.5x minus 9.7. Notice I didn't write anything in for x because we're looking for it, but I'm going to set this equal to 12.3 so that I can figure out what x would give me an output of 12.3. And I'm going to go ahead and I'm just going to make a little line there. So I add 9.7 to both sides. 9.7, and then I'm going to go over here. 2.5x equals 1, 0, 9, 10, 11, 12, 22. And then I divide both sides by 2.5. I know that I would have to put this in a calculator. 22 divided by 2.5 is not a pretty number. It's going to be a decimal. Let's see here. 22 divided by 2.5 is 8.8. Okay, this is a self-practice one right here. Self-practice right there. That's what we call function notation. You'll hear it again. You'll hear it a few times. We also have another concept to talk about. Domain. When you have a relation, the domain refers to all of the x values in a relation. And the range refers to all of the y values in a relation. And the relation can be a function, but I'm going to say relation because I don't want to leave out anything. So when someone asks you for the domain and range, my domain, I'm actually going to do some highlighting here. My domain is all the x values. So it's 1, 5, 7, 15. So I'm going to highlight this blue. My range is all of the y values, 3, 7, 9, and 17. And what I do is I write them all out. And I'm going to use set notation, 1, 5, 7, 15. The elements in the range are 3, 7, 9, and 17. You just list them out. For C, my domain would be 1, 2, 5, 7. My range would be 3, 5, 12, and 17. It's too good to be true. Let me tell you. If you have repeating things, that's fine. You just don't want to repeat them when you list out your elements. So for like the domain, I see I have 6, 7, 8, 9, 10. That's what I have to choose from. 6, 7, 8, 9, 10. Notice I am not writing 6 twice or 7 twice, because it's just like saying, I don't know, first, second, third, fourth. It's like saying how many 10th graders are on the basketball team. If you have 4 10th graders, I'm not going to say 10th, 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 or 4, 4, 4, 4. I say it once. I only have 4. So make sure you don't be repetitive with listing elements when you're doing the domain and range. When we're finding domain and range for graph relation, we use what we call interval notation. Again, you see that word notation. We see that word when we're trying to express something or write something out. Interval notation is used to express a whole group of elements, but the group could be so big that instead of listing them out individually, we will put a set of parentheses or brackets, and then we'll put the first element and the last element. So first element and then the last element separated by a comma. If it goes on and on and on forever, you would use the infinity symbol, just so you know. So what's the difference between brackets and parentheses? We use a bracket for when the element is included in the set. It's not just a starting or ending spot. And we use parentheses for when the, I'll say, starting or ending element is not part of the set. And if we use infinity, infinity goes with parentheses because we can't pinpoint something down as the end for infinity. It goes on forever. So how does this look? How do we do this? If I was expressing the domain of this relationship, it comes from negative, it goes on and on forever in both directions. So it's coming from negative infinity, and then it goes to positive infinity. That's the domain. How far left to how far right. The range is how far down to how far up. And this also goes from negative infinity to positive infinity. That is me listing all of the elements. For C, notice that we are at 2. Negative 2, negative 2, 2. So if I was looking at the domain, that's from here to here, and those 2's and negative 2's are included because it hits them. That's the domain. The range, actually, this time is the same thing also because this is a circle perfectly centered on the origin. Does it always look like that? No. But can it look like that? Sure. Let's say that this right up here, let's give these 2 different values. Let's say this is 2 and this is negative 3. My domain is how far left to right, and this is from negative to positive infinity. It goes forever this way, it goes forever that way. Weird. Okay, I think I'm still on here with my voice. But the range of this is going to go from negative 3 to positive 2, and they are included. It's touching, so they are included. And that's a thing. Sometimes you'll have one bracket and one parenthesis depending on what you're looking at. But that is domain and range. That is the end of our notes. Hopefully, you are successful with the homework that goes with this evening, and I will see you on Thursday.